am from Tennessee. I mean, not originally from Tennessee, but if it helps kind of throw the act, I'll throw y'all in every once in a while. I'll have to have some help to remember that. It doesn't come naturally. So, this is kind of a story of how I solved connectivity headaches with Machina.js, Machina.js. I was kidding, I can call it whatever you want. But some of this might be, familiar territory. I'm curious, like, anybody having to deal with online, offline concerns right now in web or mobile web or anything like that? Cool. What kind of, I'm curious if you want to volunteer anything, what kind of approaches have you taken, like any particular browser APIs you found effective, that kind of thing? Any that you found detrimental or insufficient? What's that? Yes, it is, exactly. So I mean, then you will feel my pain, which I am so sorry. But at the same time, we're going to talk about connectivity, but we're also going to talk about Machina, which means we're going to talk about state machines. And if at any point you have questions, feel free to ask. You can harass me on Twitter as well. That's why my handle's up there. But the other thing too is if there's stuff that is all kind of familiar territory for all of us, then you can raise your hand and say boring, except for Tom, you can't say boring. And we'll move on. But so Mike already said this, but I am a developer advocate for Telerik. If anyone else on Twitter, feel free to go and laugh at the code I try to open source on GitHub. But a little bit about me, kind of why I'm even here. This is my silly part of the presentation. I promise it won't always be this way. But so I love looking for patterns. I've been amazed at how they've come to my rescue in some pretty thorny situations, and they're not always obvious. Sometimes they jump out at me. And I wish you could hear the sound on this next one. I'll turn my laptop up really high. But when you see a pattern jump out at you and you realize this would actually be a good solution for this problem, I'm going to go with a first round iteration implementation of this thing I have in my brain, and you want it to go something like this. This is the best. Who does not want to do that? So that's how we want it to go. In my case, I don't know about you guys, but it usually ends up more something like this. I feel so bad. She goes all the way under, too. It's just, that's a really deep hole. But that's okay because, we can iterate and refactor. And sometimes refactoring is like this. That's kind of appropriate because there's a few silos like that near my house. And then sometimes you refactor and it actually looks like you meant to do it. I'd love to do that too. Eventually, you want to feel like this guy, like you get it right and you put your shades on. And I couldn't go with the CSI shades thing, it's just so overdone. But anyway, what I hope, as we talk through this tonight, is that somewhere we land between, yeah, I got it, and epic Santa reindeer gif. Either helpful or, oh my gosh, this could be great, I'm going to go check this out. So that's my brief detour. So really, enough nonsense aside, why are we here? I actually think that managing online and offline connectivity in apps can be done simply. You might think I'm on drugs for saying that, and maybe I am, but we'll talk about how. And then part and parcel with that is what are finite state machines, and how do they even fit into this, number one. And then what FSM behaviors are provided by Machina, so how does Machina help us with finite state machines? And then, kind of the obvious million-dollar question, how can I use this in the real world? So, what's wrong with the current browser APIs? That's kind of what I was getting at when I was asking you guys. Besides the fact that they suck, let's look at a couple of the options. These are kind of common things that I've seen. Granted, the first one's not really browser level, but let's talk about how I've seen people deal with finding out, are we online or offline? So the jQuery Ajax error event, it's a classic one, right? So you listen for it, and you're making some big assumptions, but you get an error, and you have some app that you call set status to offline. It's brute force at its best. But yeah, I mean, that kind of approach is useful, but it's blunt. And it's based entirely on failures, and it's based on a lot of assumptions about why a failure happened. But I have seen people using that as one of their means of detecting whether or not we're offline. I think it can be an indicator we might be offline. We'll talk about how we can fit that into it later. But it's definitely not sufficient on its own. And my favorite, personal favorite, is Navigator Online. So just a quick aside about Navigator Online. This next quote is from the W3C spec. Notice that first sentence, especially the last two words. It's inherently unreliable. So, well, I say that's from the spec. The hugs and kisses part's not from the spec. I mean, you put an inherently unreliable attribute and then encourage people to use it. How else can you mean it other than hugs and kisses? So my feeling about Navigator Online is summed up by that. It sucks because it is inherently unreliable. You get false negatives. And it's not just that it's unreliable, it's what your code looks like as you start to sprinkle it throughout your app. So it's kind of your typical, all right, well, if Navigator Online, then let's say the customer else do something for later, queue it up for later. I don't know about you guys, but I don't really want to have that all over my application. In part because we're going to end up in a situation where I have this branching logic everywhere. And I've got it, in a sense, procedurally check if I'm online. And this has now become a leaky abstraction into components that don't need to worry about if they're online. They just want to complete their operation. So that's one of the things that, one of the many things I would say is a case against Navigator Online. It can have some use. We'll talk about how we can graft it in a minute. And then the better approaches is actually just doing an add event listener on the window for online or offline, assuming we're in an environment that supports that. And then you can do the same thing actually with the application cache object. You can listen for error or downloading, since error would indicate probably offline. Application cache downloading event might indicate you're online. So these two in tandem are actually some of the best approaches I've seen used to kind of help triangulate, are we online or offline? But what would that look like? I mean, this is, again, quick pseudocode. But the idea of at this point, we actually do seem to have some sort of app namespace, and we're setting status offline if we get an offline event, and online if we get an online event on the window, and so on. That's better, I think, than doing Navigator Online everywhere. But I don't think it's better overall. And then the only other thing I'll throw out there, anybody doing PhoneGap, Cordova, that stuff? Cool. So you know about the connection type stuff. So again, it can be useful, but I've ran into situations, buddy of mine recently, I think it was an Android device, was reporting a 3G signal as a 2G on the connection type, or you can be unknown. So in that case, it's still not perfect. So unfortunately, what we have here are little puzzle pieces that even put together all together, they are not the entire picture, which really sucks because this is a problem that we need to address now, and it's not going to be addressed at the browser API level, and in my opinion, sufficiently anytime soon. So before we kind of move on, I do believe that having a single source of application state, like what we saw with the setting app status to offline or online by listening to window events or application cache, that's better than sprinkling that branching throughout everything like I've seen with Navigator Online. But it doesn't address some other problems. You guys familiar with the commuter problem? Yeah. You go through a tunnel on a train, lose connectivity for a few seconds. Are you really offline? You were for a few seconds, but I mean, the approaches we saw earlier are making big assumptions about going offline and haven't even addressed how long do we stay offline, all that. So, and then tied into that is this idea of false negatives and positives, the unreliability of Navigator Online, for example, or the unreliability of our connection if we're commuting, we're on a train or a bus somewhere and we lose connectivity for just a few seconds. But the thing that none of these really address properly is the user's deliberate choice to go offline. It's a big deal. So there's a difference between being disconnected and being deliberately offline. And then all of this still doesn't address testability. One of the first PhoneGap apps that I had a chance to work on was already pretty well into its life cycle, and all of the offline connectivity was done using Navigator Online, and testing that was insane. I mean, it's JavaScript, so you can mock anything, that's fine, but everything about their online-offline detection in that app was tied to the implementation, so it's very difficult to test on its own. So testability is the other thing that I don't think that none of these APIs are addressing for us yet. So this is where I was in beating my head against the wall in that particular PhoneGap app I just mentioned. Or like, we have a lot of different abstractions for similar kinds of input, but what I really want is something that reacts differently to the same input depending on the state. In a sense, I want that quintessential black box that's a nice abstraction that knows how to react properly to these different types of input I can get from the browser or from the user, and have it respond appropriately given the state that it's in. So in other words, I want this to be easy. You guys might actually recognize where this is going if you know what this table is, but it's so simple when you spell it out. If we're online and the app tries to make an HTTP request, why don't we just do this? Why does this have to be rocket science? If we're offline, then set the app to offline, and maybe, or I'm sorry, if we get an offline event, set the app to offline. And then if we're offline and we try to make that request, maybe we queue the request up. Maybe you're going to put it in local storage, and you've got some kind of synchronization thing that you're going to do later. But it's not difficult, at least to conceptually explain what we want to happen. The problem is the tools aren't there. So as I looked at it like this, I realized there's an abstraction for this, and it's a finite state machine. So how many are familiar in general, like I guess with FSMs? Yeah, this is going to be old hat. So you may not feel like Picard then. So that's cool. I did initially early on in my career, what is this state machine thing? So in effect, I'll jump through this. I'm about to commit one of the cardinal sins of presenting, by the way. We'll get to that in a second. But a finite state machine is a computational abstraction, which is just a fancy way of saying that it calculates a yes or no answer to something. So we're obviously going to be talking about FSMs at a much higher level than, say, like parsing and hardware state machines and so on. But hence the name, it's got a finite number of states in which it can exist. It can only be in one of those at any time. It accepts input, which is kind of like, duh, of course it would accept input, right? But this is important because there's a formal way, in a sense, to interact with an FSM, at least with Machina there is, but in other implementations there are as well. And it can produce output. Then that output could be determined by the state that we're in and the input that's happening, or it could be determined by the state that we're transitioning into. There's two different ways of representing FSM behavior. We'll talk about that in a minute too. And then obviously it can transition from one state to another. It is theoretically possible to have a state machine in one state, but why bother? But in this case, I put a star there to indicate too that the transition needs to be a controlled thing. I mean, in Machina it's a method call, but there is a state property that you can mutate yourself. I don't recommend doing that. That would be bad. So this is a cardinal sin, by the way. There's a lot of text on one screen. So my obligatory, I feel really bad about that. So questions so far on what we're talking about? Cool. So let's talk about a real-world example before we get back to our connectivity stuff. This is kind of your classic textbook turnstile. So now we have the makings of a not quite formal, but more formal than before, state transition table. So our turnstile can be in one of these two states. These are the inputs that it accepts. This would be the resulting state based on that input, and then output generated. This is one way of representing the FSM. There's actually a different way to represent this with the output in different spots. But so if we're in a locked state and you pay, then we're going to transition to unlocked, and then the turnstile is released and you can go through. Same thing, if you're in locked state and you push, you're not going to result in a transition because you haven't paid. So the nice thing about this is it's now starting to set up the concepts, at least, for an abstraction that knows how to properly know lock. And be like, no, sorry, I'm not in a state to even worry about that operation, so it's not going to happen. Which can be a pretty powerful thing when it comes to state-based things like connectivity. Same with unlocked, it's just the inverse, right? If you're in an unlocked state and you give it payment, we've wasted your money, it's still going to be unlocked, but there's no output. And then if you push, we transition back to locked and the turnstile is locked. So another way of representing this is to be a directed graph. So it's kind of like a squished Mickey Mouse. But the idea here is your circles are your states, right? So locked has the 1 over indicating it's the initial state. And the arrows are inputs. And if they point back to the state from which they originate, there's no transition. If they point to the next state, obviously you can see that payment causes a transition from locked to unlocked, and so on. Both of these ways are useful, especially as you're trying to reason out the kinds of behavior that you want to model. Both are I think, pretty powerful to visualize. What's that? For the win. So, sorry, that's diagrams for the win. It's a question of, hopefully it's useful to you. Maybe it's also some of my cheesy bad humor. So, if you're still awake, hopefully, the last thing I'm going to kind of go through is just sort of fine print on state machines. I have some extra reading links at the end of this too for you guys to check out. But there's two basic types, acceptor and transducer. Acceptor would be, a classic example would be on something like parser that you give it a sequence and you're looking for a particular pattern, and as long as it matches that pattern, it's said to be accepted. And at the end, if it's in an accepted state, then your input was accepted and so on. A transducer, there are two general types, more and mealy. More, the output is going to be dependent on entering a new state. So the way that we represented the turnstile a moment ago is actually this style, mealy. And this such a simple example, it's kind of hard to see the difference at this level. But the way to represent it as a Moore machine would be to say, instead of the payment input on a locked state resulting in an unlocked output on the turnstile, instead it would just result in a transition to unlocked. And as we enter unlocked would have an entry action of unlocking a turnstile. So it's, in a sense, it's a subtle difference on where the behavior happens. It's kind of a way to maybe oversimplify it, but that's the idea. In my own, kind of journey through this, I've tended to lean more towards more, no pun intended, as I've grown. It's not that one's wrong or the other. I find a neat abstraction around entry actions. It makes sense. And then as far as determinism in a state machine, this is what this basically means. If it's deterministic, it means there's only one transition to another state possible for the input that occurred. If it's non-deterministic, then 0 or more transitions are possible. Anybody using like Q or RCP or jQuery deferreds, any sort of promise implementation? Cool. You guys can't answer because you know the answer to this. Do you know why I'm asking the question? Just curious. What are promises? Under the hood. They start off unfulfilled, right? They either get fulfilled or failed. So they're state machines, effectively. So, I mean, if you're using promises, you're using FSMs already. If you've ever written a method that wraps a nice, elegant switch case, you have a mini state machine, a little state machine dying to get out and be allowed to live on its own. But anyway, this is where Machina comes in, because as I'm analyzing this connectivity headaches that I was dealing with in that PhoneGap app, I was also writing this library at the time that was sort of loosely inspired by a three-month stint on an Erlang project, because they have a really fascinating implementation of FSMs in Erlang. So I loosely borrowed. This is not a port by any means. Very loosely borrowed some ideas. So with Machina.js, the states are organized into a states objects on the FSM. This is pretty straightforward stuff. So if you have the states object, it's an object literal. Every property is a state. So the key is the state name, and the value is going to be an object. Each state object's members are functions that respond to input. And this will make sense probably a bit more when we look at some code. But I have a star by functions because there's some shortcut syntax. The input function handlers can be a string if all they do is transition to another state. So you'll see an example of that in a minute. There's an official way to transition to a new state. You just call transition and give it the state name rather than mutating the value directly. And that's because we want to control transition. There's events that could get emitted. There's certain things that internally would happen in the FSM that would allow us to do some fancy stuff that we'll look at in a second as far as replaying events. And then when you interact with the FSM, at the lowest level, the utility function is to call handle. It doesn't stay this ugly, but this is the official way to say, in the case of our turnstile, handle input name would be payment or push, and then whatever args, if there are any args. And then what the FSM handles for you is mapping that input to a handler name on the state that it's currently in. So that stuff's taken away as far as you don't have to worry about it directly. There are a couple of special handlers, input handlers called onEnter and onExit, and they are exactly what they sound like as you enter a state or leave a state. And then this last handler is a star called a catch-all handler. Basically, it's a way to give you a chance to react to input that's not already explicitly handled. And that could be interesting, like Mike mentioned that we use this for bootstrapping a single-page app. It's possible that you could get input before the FSM is really ready to deal with it. So the state that it's in doesn't really care about that, but think of it like this. The turnstile gets a push input while we're in locked state, and instead of ignoring it, we queue it up for later. And then when they pay, which is what we're worried about while we're in locked state, it transitions to unlocked. And after the transition, that FSM could say, hey, was there anything queued up? I'll go ahead and replay those now. And it sees that there's now a handler for push in the unlocked state, and it goes ahead and plays that event. So it's kind of a cool way to actually, in a sense, blast all your initialization stuff out in the FSM. Kind of like the coin machines where you sort your coins, at a grocery store. I don't know if you guys ever use those, but it's kind of, it handles those things when it wants to and puts them in the right slot. And then tied into that, that's the method you would call if you want to defer an event until a transition. The state argument is optional, so you could say defer until any transition, or no, I only want to defer this push event until, or this push input until we're in the unlocked state. And then kind of a sister function to that would be defer until next handler. So it's not going to wait until a transition to a new state. It's just going to wait until we get more input to the FSM. And all the FSMs in Machina are built-in event emitters. I tried to keep the implementation of the event emitter kind of light because this is sort of like a, everybody has their pet emitter they love, which is fine, and I want to allow that. So you can tweak that if you want, but you could just patch the prototype with the one you want to use. It's fine. I do that. I actually have an emitter called monologue that I usually overwrite the built-in one. So that was a lot of API info. Any Doctor Who fans? Yes, you'll appreciate that. So let's actually look at some code. This is finally get to the interesting stuff. Setting up an instance, you have a couple of options. If you've used Backbone or any other library du jour that allows you to extend constructor functions, Machina supports that same kind of paradigm. You can get a new instance by just saying new, or you can get an extended constructor function that you can use to make an instance later. That's the idea. But the real interesting stuff, obviously, is what goes here. What do we pass? In fact, you actually would pass the same arguments to either one. So let's look at our turnstile. As you represented. Again, this is a really simple example, but new Machina FSM, so we're renewing up an instance. Initial state is one of the values. The initial state and states really are the two main values you pass on in your options that are kind of required if you want to have a usable FSM. So we're going to start in the lock state. You can see my states object has two members, locked and unlocked. And I'm using the shortcut syntax right now because all these input handlers do are transition to another state. So I don't even have to make them a function. So in other words, locked payment string unlocked is actually the same as saying locked payment is a function where you call this transition to unlocked. Make sense so far? So just added that in because, I love JavaScript, but man, you can get verbose. So eliminating the need to just have a function that calls another function, that's a win. So this idea is pretty straightforward. The nice thing you notice is that there's nothing in the lock state that worries about a push input. There's nothing in the unlock state that worries about a payment input. You can choose to handle those events if you want, but in this case, the FSM is going to ignore them because it's kind of invalid input. It's not ready for it right now. If this were a more complicated turnstile that needed to remember things, then sure, we could defer events or emit some sort of error event. But I mentioned earlier that the formal way at the lowest level you interact with the Machina FSM is by calling handle, and it handles there for you to wrap. So you could do this if you want. I don't recommend it. I just don't consider this readable, and now you have magic strings floating around. But the idea is you could say, we're starting off in lock state, so turnstile, handle, push. Sorry, you got to pay first. So you handle payment, so we would transition to unlocked. And then handle payment again, well, you wasted your money, no big deal. And then handle push, yeah, you get through. So that's one way to do it, but what typically I would recommend doing, and this is what I do, is handle's there for you to wrap with a more expressive API. So this is a low-level utility library. It's not meant to make the intention is not to make a lot of assumptions about the domain you're solving for. So instead, I'd have a top-level push or pay function on my FSM that would wrap a call to handle. So that's a bit more expressive as an API, in my opinion. Yeah. Make sense so far? Cool. All right. So, great. How do we apply this? It's about time you got back to the subject. So what does this have to do with connectivity? So we talked about online and offline. There's really more than that. And I'm going to make the argument that offline right now is because the user said so. And that means that we have another way of being offline, and it's disconnected. I lost my connection. Oops. But this isn't everything. And there's actually a fourth. Sorry, my voice is going. Anybody have any guesses of what the fourth state would be?
Connecting. That's
a good guess, yeah.
Server dev?
What's that?
Server dev?
It's a good guess. Yeah, these are all great guesses. I got some experience with this today flying here with the TSA. I call it probing. But yeah, connecting or detecting is actually a better, probably detecting, probing. I would say that we need something to represent finding out, because that's the thing. If we're relying on the browser, what's there? Events? Well, anybody can emit an event on the window to say we're online or offline. We know that Navigator online is inherently unreliable. And we have a horrible case of being able to be hijacked at any moment by an unintentionally malicious junior dev code or senior dev code. I would do that too. Probing is really a spot for us to determine how do we officially determine if we're online. And this is the crux of the matter. I don't think that you can decide this at the browser level. Maybe I'll get proven wrong. But think about it. I mean, what's online in your app? What's offline in your app? Our needs may differ. You may have WebSockets and HTTP. I may be HTTP only. That sort of thing. You may have the situation where the user doesn't get to say go offline. You just handle all that behind the scenes. So the question of are we online or offline has to be answered, I think, in a way that's probably more app specific. And you're going to typically need to reach out to an endpoint, see if anybody's out there, right? So if you're using HTTP as your primary transport for communications, you're probably going to be hitting an endpoint somewhere, see if you get it 200 OK, or WebSockets emitting something up the event, emitting an event up and getting a response back, something like that. So that's what probing is all about. So let's take these 4 states and go through the exercise that we went through with the turnstile and kind of put this stuff out into a state transition table. And I'll take it a state at a time to avoid any more cardinal sins, too much text on the screen. But this is the idea. We have an online state, and these are the kinds of input that we could assume early on. Now, there are other things. Like I'm not assuming a phone gap app, for example, but if we were dealing with phone gap, we could easily add another input for device resume or something to that effect. So if we're in online state and we get an input saying we're offline, or there's an app cache error event, or let's say we're using our Ajax error event and we're listening for request timeouts so that we can feed that as input to the FSM. If any of those things happen, we don't just assume we're offline. It's just an indicator that we might be offline. So we go back to probing, and whatever heartbeat check we have set up would run, and then it could determine what state to go into next. The only thing we would, in a sense, directly move to in this case is that the user says go offline, and then we would move to offline. And then the output for each of these is just emitting an event. Our FSM's an event emitter. It's a nice place now, for your other components in your app to observe that. This is great use of the observer pattern. So this keeps that concern from bleeding into other components in your app, which is kind of cool. The offline state's really easy. It handles one thing, because this is when the user said go offline and stay offline until I say so. So it's going to listen for go online, and it's going to go back into probing, because there's no assumption that we really can be online at the moment. We're going to go check and see if we can be. Disconnected is going to look like the inverse of online. So we're going to listen for the user saying go online. They're like, no, please try again, Or go offline, which is like, no, I don't even want you to try to go back online right now. Just I'll worry about it later. Or we're listening for window online or app cache downloading, something to that effect. You could even have, if you wanted a heartbeat polling constantly at some interval, and it could feed input, that we may be online here. And then again, we just emit events. That's our output in this case. And then probing is pretty straightforward. We're going to listen for a heartbeat event. So it's up to you. Like I have an example of one here, but you would just write your own heartbeat check. Is it checking an endpoint or a WebSocket connection or something? And if so, we would transition to online if we get a heartbeat. The assumption, too, is that you'd have some sort of timeout, right? So you check your heartbeat, and if you don't get a response within 5 seconds, maybe assume you're disconnected. That kind of thing. And then so no heartbeat would move you to disconnected. And then it's possible, theoretically, for the user to intervene before the heartbeat response comes back or before the timeout happens and tells your app just to go offline. So that's why that's there. So that looks frighteningly big on all on screen. So there's your kind of your stock Nicolas Cage meme. But so let's look at this before we look at code 2. One more, I promise. Visualization, and that's the directed graph version of what we just looked at. I find this kind of thing to be very helpful to me, especially when I'm dealing with what seems to be more complex behavior than what it actually turns out to be. So hopefully so far, this is not seeming as crazy as it feels like when you're trying to, kind of like when you're in the trenches trying to tackle that connectivity issue. So going through one state at a time, you've got a probing state, you can see the events that we handle. Now I put this queued, that's the star handler, it's kind of hard to see, but you have the option in Machina to delay any other input and have it replayed at a later state. So that's up to you, but that's why that's there. Online, these are the things that would ship us back over to probing, or go offline, which takes us to the offline state. Disconnected, inverse of online. So these are the things that would put us back in probing, or if the user said no, go offline, don't try to come back on. And then offline responds to I'm going to go online. So, finally, code. So I'm going to have to zoom because this is going to be interesting. Hey, is that kind of you? Cool. So I've collapsed this down to give you one of the things I love about this is it's really easy, especially with the states being top level members of your states object. It's easy to see as I look at an FSM to see what it does, what states can it be in probing, online, disconnected, offline. So everything we just talked about. It's really nice to have that one-to-one analog here. And if I want to expand these, I'm taking advantage of, whoa, hang on. Lose my, there we go. So in probing, we have an entry action. And I've obviously got some white space issues, maybe it's just wrapping, but stethoscope, I have to come up with creative variable names. But this FSM is making use of the stethoscope, which is how we're checking the heartbeat. And all that is something that reaches out and talks to, in this case, a fake endpoint, because I'm using mock-jacks. But you can see, I'm giving it some endpoint to talk to via a definition, and by calling check heartbeat, it's effectively going to emit an event, either checking heartbeat, heartbeat or no heartbeat. So the FSM takes advantage of that. So I use the stethoscope, and that's the entry action as we go into probing. So we only do that once because I'm seeing if we're wired up already or not with the heartbeat check. But then everything else past this entry action is pretty straightforward. Using the shortcut syntax here, so if we get a heartbeat event, we just go to online. If we get a no heartbeat, we go to disconnected, and so on. So it's actually, hopefully, if you feel this way, I look at this and feel like it's fairly readable from the standpoint of I can parachute into this FSM if someone else wrote it and be like, oh, okay, I got the gist of what's going on. And then we have a catch-all function just to show you as an example what this could look like. Any input that happens while we're in the probing state that's not explicitly named, so it's not heartbeat, no heartbeat, or go offline, will get dropped here, and then we're just deferring it until it transitions to another state. And then online and disconnected and offline are going to look really simple. It's one thing to try to endeavor to keep your methods from being too long. It's one of the things I like about just using the shortcut syntax is if I can go that route, in a sense I've abstracted stuff I would be tempted to put in a lengthy input handler. So in this case, I'm just worried about transitioning because I want this FSM to be sort of the canonical one version of the truth, are we online or not? And then you'll see disconnected, it's going to look really similar. It's the inverse of online. And then offline. Bam. So I have a simple example of one of the co-contributors on this, Doug Niner, really talented JavaScript developer and designer, put this together with me. Let's see here if I can scoot this over for you guys to see.
So is this a mocking framework, or are you using another mocking object to drive? I guess, what are this whole framework is the mocking framework, or are you using a separate mocking?
So, you may be asking that because I mentioned mock-jacks.
Right.
I'm using mock-jacks to emulate an HTTP connection, because that way I can just run it, using Python local web server. Not to worry about stuff. But Machina itself is not a mocking framework, and I've never really thought about the similarity in the name sounds. In a sense, what we've done with this FSM is we have put an abstraction between us and the various browser APIs on dealing with connectivity. The nice thing about it is it would be very easy in tests now to mock the browser, to mock these events, and then test your state machine and see, does it respond as we'd expect. So this is kind of just a simple example showing you that the FSM I showed you actually does work. I'll drop this down by opening the box up, hooked at this just to be fun, but this will slow down the transitions with about a 2 to 3 second pause between each one. So we're starting in offline. We tell it to go online. You can see the transition from offline to probing. Now we're in probing. We're doing a heartbeat check. We've got a heartbeat back from our fake endpoint. Probing to online, now online. Now I can break the connection and simulate a window offline event. and then we go back to probing. And this is why I use mockjacks, because when we break the connection, I'm just changing my mockjacks definition to return a 500 instead of a 200. So that gives you the idea. Now we're disconnected. If I go offline here, it just goes straight to it. And you'll notice, once I let it transition, giving a window online event while we're in offline state doesn't do anything, because that's the way that this, in this particular case, the user doesn't want you to try to go online. They told you to go offline. So that's what I was getting at earlier when I said there's a powerful way to no-op input in your app. You're like, no, we're not in a state to really deal with that. Now it's up to you if you feel like you need to queue that up for later or emit some sort of event as a response. But it's really nice to be in a situation where you'd be like, I got nothing. We're not online, so I don't care about that event. So, questions so far? Fire away.
Does this actually work for different states besides offline and online? Can you, like, if I wanted to determine or think of different states that it could be in, could I put those in as well? Or?
Absolutely, yeah. If you like, the interesting thing, the app that I worked on, the guys that are here from Pearson, had some really interesting aspects because it utilized WebSockets and HTTP. And my temptation early on was to try to meld those. And this is where you get into, for me, it ended up being a big code smell. Here's why. What we're really getting at is, so you have an app that's got HTTP and WebSockets. What defines online? Do they both have to be online, or just one? So now you get into partially online, and it's just totally fine. That's not a big deal at all. I mean, you look at libraries like Socket.io, and they've got internal fallbacks that are already kind of doing this stuff internally anyway. So the interesting thing there is you would actually have, if you're just dealing with connectivity, so I'll answer that part first. You could have a WebSocket connectivity manager, if you will, and an HTTP connectivity manager. And then when you get into hierarchical state machines, you can have one that's more of an aggregate that could say, we're in HTTP WebSocket online, we're in partial, or we're in HTML or HTTP only, or WebSocket only, that kind of thing. And in a sense, now you have your abstractions that the one that's just worried about WebSockets, the one that's just worried about HTTP, they don't have to worry about each other at all. You have this higher level, hierarchical FSM above that says, I am concerned about both of you guys, and I may not react if you both go offline, but I might want to react if only one of you does, or that kind of thing. So,
well, I was thinking more in terms of the state machine to determine what browser.
Oh, interesting. I guess you could. I mean, I don't recommend UA sniffing, but, you didn't hear it from me, but yeah, you can try that. It would be interesting too, I think about it like where UA sniffing still kind of not entirely frowned upon is mobile OS detection in hybrid apps, which would be an interesting.
Sort of my thought is like, yeah, sure, if you're just doing sniffing for like, if it's IE or Chrome or something, that's no big deal. But I mean, given that there's so many different possibilities now, and there's a lot of crossover between what you can do in the different possibilities.
Yeah.
This actually seems like a slightly more elegant solution to it.
That's really interesting. I love this because I hadn't thought about that avenue of it, but that's the fascinating thing about this abstraction is it tends to, it really is FSMs all the way down. Somewhat facetiously, Mike's like, yeah, I know he means it. But one of the things that's a great point because one of the apps I worked on with a friend of mine recently was just a demo app of some custom Cordova plugins on a PhoneGap thing. And we found a great one for iOS and not one for Android, and vice versa. And that would be an interesting scenario of having kind of the state of saying, well, you're in iOS, so you get these things. And depending on how you abstract this stuff out, I might get into this in a second, I think. But sibling and hierarchical FSMs, still not a great way to model this stuff yet in code, in my opinion. I'm trying to work on a better API for that stuff. But let's pretend there was a great API for it. You could have, in a sense, state-driven views that know what menu options automatically based on the environment. I mean, we're doing this stuff anyway, right? We're detecting it in some way. But having it formalized so that it's like, oh, well, I'm basically feature detecting based on what plugins I see available in the OS that we're on. Here's your menu. Oh, and by the way, this is also what's allowed in the app. And that's really, I don't know, it's cool. But as far as other states in general, this problem goes well outside of connectivity too. We used it for initialization at Pearson, and we did it for identity refresh stuff in the background, and I'm trying to think some of the other. Used it for I've brute forced Machina FSMs on the backbone views, and got that idea from a friend of mine named Alex Robson, and we call it view machines. You know, it's state-driven views. Now they're didn't you say React is doing that kind of thing now? State-driven views or something? I don't remember. But now there's probably maybe better ways with UI frameworks now than that. But that's the idea. In fact, we'll get to it in a second if I have time. But anyway, was there another question? Do you have a question?
You answered it during that answer. So.
Oh, cool. That sounds good.
So one of the interesting things that's come about is people are wanting to implement distributed data protocols. Essentially, say, if the user goes offline, still allow them to log data locally and then synchronize with an API or an endpoint. And so, I don't know, have you seen either this or other implementations, state machines pulled in to kind of help determine online, offline, and then kind of synchronization?
It's a great question. I haven't, unfortunately, dived into any of the newer synchronization, like they're apparently offline.js that just hit JS Week like in the last couple months. But I think all they're doing, don't quote me on this, I think they're just queuing and then resubmitting the request when they come back online. And see, this is another, I mean, man, our clients are becoming nodes on a distributed, I mean, they already are nodes on a distributed network, but I mean, good luck with all the server-side architecture that's currently like last right wins. I mean, that kind of stuff's going to cause some major headaches. So the synchronization thing's a big deal. I haven't, I do know back when I was working with these guys that Socket.io has at least some level of buffer to where it will resubmit, at least at the time it did. I don't know if you remember that, but they had some sort of thing internally where I could, if it was currently negotiating to try to reconnect and I had some admitted events, it would actually replay them with the socket again. So are you saying that people are actually coming up with a protocol to kind of formally handle the synchronization stuff? Or?
I've heard it talked about. So there's a framework called Meteor.
Yeah.
And so one of the things that they're trying to evaluate is how do you do online, offline. And so they have this, what I understand, which could be wrong, a mini Mongo plugin, so that when the client receives data, it goes in there, and so all interactions, all the reads and writes happen at the client first, and it can't be answered at the client. And we go back to the API where data is being sent and received.
Interesting.
So I don't know how mini Mongo kind of handles either online or offline. It may be something that don't even facilitate.
Yeah.
But I was just curious because it seems like there's either an intersection or a possible real mutual benefit.
Yeah, I definitely agree. I have the guy I mentioned earlier, Alex Robson, is working on some stuff that it either is or will be open source that has to deal with he's writing some Erlang and .NET tie-ins for React, and it has to do with dealing with distributed reads and writes and so on. And that I'm going to totally butcher what he's working on, but the idea is he's had to work through algorithms to kind of have almost like how we deal with Git, right? I mean, you've got a baseline. And you have these writes that could happen from different clients at different times, and you can't just go with last write wins. How do you merge these conflicting branches in and so on? The tricky problem, this is why the protocol part sounds really interesting, the tricky problem is, so far when anybody's ever promised me synchronization without a back-end stack that already does it too, like I'm suspicious because I'm like, I mean, our sync needs are going to be not only app-specific, but there's going to be some level of back-end assumptions that have to be made that we interact with. And protocol would be, it seems like it'd be an ideal place to be. So yeah, it's an interesting question. So real quick, am I doing okay on time? I'm happy to, whatever. You guys throw tomatoes or something?
Yeah, 10 minutes. 10
minutes, yeah, sure. So one other thing I'll talk about, let me jump back over to this, because I hinted at this, and this is part of why I feel like it's, oh, by the way, that's how I felt about the online, offline stuff after we kind of went through the state machine abstraction over it. It's like, God, was this hard? It shouldn't have been that hard. This was simple. Maybe I'm missing something, which always can be the case. But I did actually kind of pull one thing out, this is why I wanted to go through this. So remember early on I said, wouldn't it be nice if we're online and the app wants to make a request that we send it to the server? If we're offline, we queue it up or local storage or something. Well, all the stuff we just looked at doesn't have anything to do with communications. It just has to do with connectivity. And there's a reason for that. I think it's because they're separate concerns. So the idea is you would have sibling state machines where you have a connectivity, one that is pretty much what we just looked at, that says I emit events, and you've got a communications FSM that's listening. And if our connectivity FSM transitions to an online state, it's going to emit an event. It's one of the Machina built-in events. You can emit custom events too. It's not a problem. So then the communications FSM would transition from a queuing, I'm just assuming brute force stupidity here, but queuing to transmitting. And then if our connectivity FSM reports that we're offline, then we go back to queuing up. I mean, this is the idea of sibling state machines. It's a pretty powerful way, I think, to work on that stuff. And then I have to throw in my favorite Yoda GIF. So if you get asked, did you solve that in a good way? Yes. And the other thing I want to jump at, because we got a really fun demo of this when it comes to state-driven views. It turns out, obviously, this pattern works well in other scenarios. Complex UI workflow, like wizard-driven stuff, or state-driven rendering, and so on, and initialization, which we talked about. So I have this app. Let me see if I can fire it up real quick. Put this together for a web workers talk. So hopefully, oh, I think I already have it open. Sweet. Okay. Yeah. All right. So you're going to see my ugly mug here in a second. Let me zoom in. I'm going to turn it around, so you guys are going to be on this too. So this is actually an app. I stole the mother effing GIF library implementation or whatever that Paul Irish and some of those other guys did a while back. I grabbed that and put it into a web worker, and but that's not really, that's just the fun part. But what I want to explain is, any backbone devs, by the way, in here? Cool. Not that that matters, but this is a backbone-driven app. But there's just really effectively three views. This top bar is basically an input form. This white area right here is currently a collection view. It's going to load up child views. And the child views that get loaded are going to be state-driven views. So you're going to actually see I think it's at least 3 different states that it appears in. And what's going to happen is I'm going to capture 10, like right now the defaults are 10 frames per GIF at 500 milliseconds each, and then once they get stitched together, they're going to be 250 milliseconds apart, so it'll be twice the speed. And the web worker's going to patch all this stuff together for me, send it back, and you're going to see the progress of that as it renders and so on. So let's be silly here. If I can find my mouse, here we go. So there's, do something like use your inside eyes. So, rendering GIF, right? So there's, yeah. So that's the idea, and it's going to keep capturing because I have it turned on. So that's the second state. So you can see capturing, and then the progress, and then an indication that it's rendering, and then now you have the picture. So there's really 4 states. And the nice thing about that is, you know, it's a composite view in a sense from Backbone's perspective. That there are 4 templates involved in that, but it's all getting rendered to the same chunk of DOM. But I don't want the image stuff to be rendered empty until it's ready and stitched. So this is going to get a bit out of hand. Not that you want to see all these. But the fun part about that demo is that I have to get one of you guys. All right. So, let's see. Get ready to wave. Or do something crazy, I don't care. Here it comes. You gotta move. Yeah, you gotta move around. It's thinking about it. There it goes. Yep. Wave, 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 wave. People.
Do a recursion with my laptop. And that's...
Let's get a couple. Who am I missing? I think we need to get one over here with Mike. Mike, you need to do something crazy. He's checking his email. He's like, what? We're talking? All right, anyway. So the last thing I'll show you then is the implementation of that view. It's really not bad. I'll show you the states. Hey. And I'll zoom in. All right. So, there's my state machine. Let me zoom in. So you can see this nonsense. Oh, go away. Initial state, capturing. So that's when we're capturing the frames. And it's, rendering a particular template, and it can handle a stopped event if I stop it before it's done. And then, assuming I don't stop it, we have a stitching state, which is where we're getting progress reports from the web worker saying, you're 10, 20, 30% done. Rendering, which is where you see that it's done, this is how many frames, this is how long it took, but we don't actually have that data from the web worker yet back in the main UI. And then when we actually get the rendered GIF. So at this point only, do we delegate the events to let us download the picture or change the name or delete it and so on. So it makes sense? It's good.
So did you write this just to get the state? Just to get the state of browser connection state? Or this is just only an example? I mean, I'm just curious because I'm sure there's not the library that detects the state of the browser, right?
No, so I'm sorry if I haven't communicated clearly too. This is actually nothing to do with connectivity state at this point.
Gotcha.
So I did not write Machina just to deal with connectivity. It's actually one of the first areas that I realized that it could be really useful in as far as on the client side. Then you're right, yeah, there are plenty of libraries, but I mean, it's kind of like the XKCD of how standards get made. That's how the browser APIs have been made when it comes to connectivity, and they still all suck. I think it's up to us to actually have good abstractions. You don't have to use Machina, but you're going to end up doing something similar if you want to better triangulate, use the APIs that are available, but then also still allow for good testability, deliberate offline choice on the user side, and then also whatever other custom parts of the app that can say go offline or on. But yeah, in this case, I was just showing this view, and that we're using a state machine to manage what gets rendered to a particular chunk of DOM at a given time. It's really, in most cases in the past, I've seen that solved through a bunch of if branching or selection stuff. So anyway, that's kind of the gist. These slides are on. Let me find the link somewhere. One sec. Just jump through here real quick. Talk about what the pros and cons are. Here's some additional reading links, and this is the link to get the slide deck. It's in a couple of formats. I use Keynote, so I tried to give you a PDF or straight HTML export as well. And then the projects, if you're interested, Machina and the GIF stitch thing that I used as an example a second ago are all on my GitHub, github.com/ifandelse. Feel free to pull them down and pull them apart. So, awesome. Thanks, guys.